everyone, and welcome back to Well Aware. Last week, we discussed a study on how biodegradable polymers can impact tensile strength and biodegradability of sutures. Make sure to check out our last episode, Snitches Get Stitches, to hear all about it. The project we are going to be discussing today is multifaceted and involves several mini experiments that were done on well water. This was a personal study I conducted as a student researcher, so let's get into it. This project began when a panel of local officials brought to my attention a possible connection between Parkinson's disease and well water. Because I have a well at home, I became very interested in this project and began to look into this possibility. I became even more interested in the project when I realized that according to a study by Jankovic and Tan, which was conducted in 2020, Parkinson's disease is at risk to become a worldwide pandemic by 2040. This is concerning because Parkinson's is a highly neurodegenerative disease, meaning it breaks down your brain function over time. If drinking well water is in fact tied with Parkinson's, this statistic was enough for me to investigate. After further research, I realized that drinking well water contaminated with certain products could in fact lead to Parkinson's or other diseases. This came from a 2021 study by Shi, who advocated that lead presence in well water was likely to cause Parkinson's. After extensive investigation into this topic, I decided the purpose of my experiment would be to test well water from various sites in Lancaster County for lead, bacteria, and chlorine. Before we begin, I would like to discuss some research that was done because this field of study is relatively new. Parkinson's is a complicated disease to study because it does not have a cut and clear cause. Instead, several risk factors are identified in environmental and genetic categories. The genetic risk factors are rather complicated to discuss. However, environmental risk factors are everywhere, especially in Lancaster County where many people have wells. The contaminant with the strongest support for connection between Parkinson's and well water is lead. Lead is toxic to the brain and can block the production of dopamine in the brain. Essentially, if lead is ingested, the brain will not be able to function properly. A study from 2021 by Schwartz points out that areas with higher levels of lead service lines correlate with more Parkinson's cases. If this is true, it is probable that water contaminated with lead could also create a spike in Parkinson's. Another possible water contaminant that could cause Parkinson's is bacteria. A study by Van Wyck highlights that protein chunks in the brain that cause Parkinson's originated in the gut through basic E. coli bacteria. Since about 40% of all Lancaster County wells tested positive for bacteria in a Penn State study, the high presence of bacteria in the area could contribute to Parkinson's. So what did we actually do in this study? So basically, I went out to 4 different locations in November to collect water samples. This is important because weather conditions can impact what contaminants may be in the well. 2 of the locations I went to were able to distinguish between filtered and unfiltered water, so I got samples of each. My experiment testing for lead is the most important in regards to making a connection between well water and Parkinson's. The way we went about doing this was unique and took a lot of improvisation as well as trial and error. Lead was tested for using emission spectrometry. Basically, a cable was attached to a ring stand which could read the emissions level of a flame. When chemicals are placed in a flame, they emit a certain intensity which is used to calculate how much of that chemical is in a sample. This calculation is made by making a calibration curve, which is done by creating a line of best fit using known concentrations. For this experiment, lead nitrate was used for the calibration curve up to 30 parts per billion because this is double the EPA limit. Then each of my samples were tested in the flame using a sterile Q-tip. The intensities were kept and then the concentrations were calculated using the equation provided by the calibration curve. As a result, the only location with a significant amount of lead was location 4, which on average contained about 17 plus or minus 5 parts per billion. This level is over the EPA limit, and at this level, the water should not be drunk. Because of this discovery, all of my locations were notified of lead testing and informed of the average concentration between all locations. This was done anonymously to protect myself as a student researcher and my institution from any financial liability. Recipients of the letter are also encouraged to get their water professionally tested if they have concerns. There was some confounding information from the test for lead. One of these concerns is that even distilled water had a slight lead concentration. This, however, could be due to limitations with the emission spectrometer because this is not the most precise form of measurement. Something more precise would be the use of atomic absorption spectroscopy, and this could be a great extension of the project in the future. This is a more complicated process and uses advanced technology to determine concentrations. In regards to lead, it is also important to consider the oxidation reduction level, or ORP, of water. This occurs when water becomes acidic and its pH is changed. This can cause water that was once safe to become dangerous because more acidic water may erode lead pipes in plumbing systems. This is exactly what happened in Flint, Michigan years ago, and is why it is important to have water checked regularly. The second mini experiment I conducted was a bacteria test. As I talked about earlier, bacteria is so common in Lancaster County water, and a sample containing any coliforms is over the EPA limit. These experiments were conducted in a sterile environment to protect against any bacteria that may have been on materials, in the air, or on the table where the experiment was being conducted. To summarize the process for this test, a food called M. endo broth was put into a petri dish, and then each water sample was flushed through a filter paper on a vacuum syringe. The papers were then put in the petri dishes with food and incubated to see if bacteria would grow. The only samples which had significant bacteria growth were the unfiltered samples. It could be concluded that there was a difference between filtered and unfiltered water, which is a good sign as long as the unfiltered water is not being drank. Additionally, location 4, unfiltered water, had more bacteria than location 1. These results are not surprising given research bacteria levels in Lancaster well water. It'd be very interesting to continue investigation into this risk factor to see how well water impacts the gut biome, which could potentially block production of dopamine. Lastly, chlorine was tested for. Chlorine is a typical cleaner of water. However, when too much is used, toxic byproducts can be produced which are known carcinogens. This test was the most basic out of everything I did, as the process was very similar to how pool water would be tested for chlorine. I tested for free chlorine, which is the chlorine available to clean the water, and these levels were almost zero in all of my samples. I also tested for total chlorine, which is both free chlorine and complete chlorine, which is what has already used its cleaning properties. Not surprisingly, these levels were slightly higher than the free chlorine, but no well water samples had significant levels of chlorine. This actually makes sense because well water is not typically treated with chlorine, tap water is. Out of curiosity, I tested tap water for chlorine, and it yielded higher concentrations than the well water did. This is because public water is more likely to be treated with chlorination. This being said, no other country uses chlorination as much as the United States does, and it is even out of practice in many European countries. This raises the question of why we still are even using chlorine. To summarize the conclusion of this project, the original hypothesis was partially supported only due to student limitations. I was unable to include actual Parkinson's patients in the study, however doing so with a large sample would be key to implying any type of causation. Something like a matched pair experiment with Parkinson's versus non-Parkinson's well water could be done to advance this project, but it's very hard to limit confounding variables, especially as a student researcher. An additional advancement of this project would be to test water for pesticides or nitrates, because these are especially prevalent in Lancaster County due to all of the farms. This trend is seen among the Amish population, as in a study by Goldenberg in 2020 that found this population has early onset Parkinson's symptoms. This is because of close proximity to pesticides without adequate filtering. We want everyone to be aware of this project because it can include a large group of people. In fact, 13% of the U.S. population gets their water from a well, according to McDonald and Gibson. Though our audience is likely large, we want to target doctors of neurodegenerative diseases as well as water specialists. This is a topic that lacks significant research, and I would love to see this advanced. Before we wrap up for today, there are a few thank yous I want to get out there. First and foremost, I would like to thank my teacher and mentor, Mr. Balmer, for all of his support throughout this project. I could not have done it without him. Additionally, I would like to thank the Warwick Education Foundation for their kind financial support. I would also like to thank the school board for allowing this class to run. I would also like to thank Ms. Griffiths for her assistance with the bacteria test, as she is an expert in this realm. I would also like to thank the North Museum Science and Engineering Fair for allowing us to participate as students for free. I would also like to congratulate everyone in my category that competed and did so well throughout the fair. If you have more interest in this project, I encourage you to check out my research paper, which is linked in the description. I am so glad you joined us today. You are now well aware of how groundwater connects with Parkinson's disease. I'll see you next week.